We're going to be spraying a two-component synthetic latex air barrier product on this wall. Okay, since this substrate isn't completely smooth and flat, we're going to go through and patch it with a latex caulk. Just a simple painter's caulk. And any holes, voids, dips that we don't like, we'll even them out before we spray on the air barrier. And these are a few of the things we're looking for when we apply an air barrier. When they use a block like this, there's no way to put an air barrier over that. So what we do is we come through with a polyurethane foam, we fill up these holes, we'll cut this off flush, and now we have backing for our membrane to go across that. We'll be applying this product at 60 mils, and we need to achieve a continuous membrane with no holes. Jim's going to put a mill gauge to make sure that we've reached our 60 mils of thickness. That's what's required by the manufacturer to achieve an air barrier on CMU. This product's not real fussy about moisture. The wall can be slightly damp, it just can't be running water off of it. Temperature, we can work anywhere from about 10 degrees all the way up to 100 degrees without any problems. Okay, on this particular wall there are no penetrations, but if there was a pipe coming out of the wall, we would foam around the pipe and then we would caulk on top of that to make sure we have a nice smooth surface and bonded, and then we'll come in and spray the product on top of that. This is a two-component product. There's a part A, which is a hardener, and part B, which is a resin. And these two will come together right here, and they'll pass through this, and then they'll hit a winder where they're mixed together, and then the two come out as one product. Okay, because it's pretty breezy out today, we're covering up the power boxes just to make sure that we don't spray liquid rubber all over them. Some does get on the power box. It's not a big problem. As it dries, it's just liquid rubber. It can be wiped off. Okay, Jim's gonna start spraying this out, and what you're gonna notice is that he sprays one direction, and then he'll spray a kind of a crosshatch pattern. And the reason we do that is to make sure that we get any voids filled. The other reason is when you have brick ties hanging out of the wall, you need to hit them from many different angles to make sure that you get coverage around that brick tie. It's the most likely spot to have a hole in the membrane. What we're looking for is to make sure that everything is filled around this brick tie. You can see over here where he's only done one pass, you can see the CMU underneath that. And this would definitely require more passes to be an air vapor barrier. Whenever you're looking at an air vapor barrier, you're looking for any of these type of openings, because that's going to allow air to go through this membrane. You have to have the membrane solid, one continuous membrane. You can see the CMU right there. You can see a hole right there. You can definitely see a hole right there. And that's unacceptable. And that's, you know, part of the reason the membrane needs to be, or the CMU needs to be real flat. Our favorites if they will tool the joints. That makes a big difference.